All right, guys, this is just hopefully going to be a short video finishing up worksheet 2 so that you are able to finish worksheet 3 and be able to write an equation of a parabola for the quiz if it's on there. Okay. So first of all, I'm just going to revisit the whole idea of parabolas. So this is where it is on our sheet. If the x is squared, okay, if the x is the squared term, it opens up or down. And remember, sometimes on the worksheet, they manage to flip-flop those sides like that, okay? And if the y is squared, then it's opening left or right. And we're going to follow those recipes. I am going to go back and talk about this one, I think, that we skipped. This should be on worksheet 2. And so I'm going to kind of fly through this one. Let's see, I'm going to do number 2 here first. Okay, so we would have written this as x plus 1 squared equals y minus 3, which is an x minus h squared equals 4p y minus k. So we'd have h is negative 1. 4p is equal to 1 up here, and here k is equal to 3. So the value of p is 1/4 or 0.25. All right, so then we're using our reference sheet, and an x squared means it opens left or right. I'm sorry, up or down, just kidding, up or down. And p is positive, so it's going to open up from a vertex of hk, which is negative 1, 3. And it's opening up, okay? And remember what I said, when p is really small, it's just going to be super narrow, okay? So if you want to just draw that bad boy, I'm fine with that. And then the other two things you're supposed to come up with are the focus and directrix. I don't ask on the quiz for the axis of symmetry. The axis of symmetry would be right down the middle. But on your sheet, when it opens up, it says the focus is at h comma k plus p. So if we have negative 1 comma 3 plus 1/4, we could just say that the focus is at negative 1 comma 3 1/4 or 13/4 or 3.25. And that would be right inside here is the focus. And then the directrix equation on your sheet says y equals x minus p. So that would be y, or k minus p, sorry. Y equals 3 minus 1/4, which is 2 3/4, or 11/4, or it just 2.75, but it's a horizontal line right down here. All right. One more example. Actually, this one is very similar. If I slide this over to the other side, 4p is still 1. This would be y minus k squared equals 4p x minus h. And k would be negative 3. H would be negative 2. 4p would still be 1 on this one, so p is 1/4. It's positive. It does have a y squared, so therefore it is going to open left or right. And this one is positive p-value, so it's going to open to the right. Oops, vertex is hk, which is negative 2, negative 3. Negative 2, negative 3, opening to the right. It's very narrow because the p-value is less than 1. So I'm not going to worry about accuracy. And basically p is 1/4 of a unit inside here. and the directrix is 1/4 of a unit back that way. That's the conceptual definition. So in terms of writing the equation, when it goes sideways, the focus equation is h plus p comma k, which would be -2 plus 1/4, which if you do in your calculator is a -1.75, and then k is still -3. So you go a little bit less than 2 and down 3, and you can give me any version of that decimal. And then the directrix, the equation is x equals, because it's a vertical line, and it's h minus p. So that is, let's see, h was -2 minus 1/4, which would just be -2.25. So it's a little past 2, and it's that vertical line. Okay, so that was a quick review of those. Unfortunately, they both had the same p-value. But then I want to talk more about completing the square. I don't know if we did, I don't think we did this one yet. I'm going to move the squared term over to the other side so that it's positive. So I will leave the x and the -97 over here. Maybe we already did this one. And then I'm going to add the y squared and subtract the 20y over to the other side. Then we only need to complete the square on this side, so we take half of this and get -10. And we square it and get 100. And when we added that over here, we got x plus 3. And there would be a 1 for the 4p out here, and this would be the x minus h, and this would be the y minus k. And you could flip-flop sides if you wanted. All right. Number 7, I think we might have done this one too, but you're going to take the 2 out of the 2y squared terms. So you have a 2y squared. If you divide -24y by 2, it'll become -12y. And then I am subtracting x and 72 over to the other side. Okay. And then I complete the square here. So I get y minus 6 quantity squared. I still have a 2 out front. When I square that, it's a 36. But when I add it to the other side, remember it's 2 times 36, which is actually 72. So this comes out to be 0. And we just get equals -x. And then our 4p is supposed to be over here with the unsquared term. So I'm going to divide both sides by 2 so that I have a y minus 6 quantity squared equals a -1/2 x, or x minus 0 if you were worried about the x minus h business. Okay, I think I did both those in class actually. All right, let me go on to number 8. I don't think you have one in your homework where there is a coefficient, but you do on ellipses and hyperbolas for sure. So we're going to take a 3 out of these two x terms. That'll leave an x squared minus 8x plus blank. And then I'm going to subtract the non over to the other side so that we have a -y minus 49 plus a blank. Then I am going to complete the square by taking half of this, so it'll be x minus 4, and when we square it, we'll get 16. Over here, we'll have -y minus 49 plus, this is going to be 3 times 16 that goes in this blank. And maybe I'll just write that here. If I erase, if you add -49 plus this turns out to be 48, you get a -1. Couple things, this form is not, we don't want this on this side, so we're going to need to divide by 3. Doesn't really matter when I do that. If I divide the 3 over to the other side, I'd get a negative. Ugh. I'm also going to take a negative out. So I'd have a negative, take it out of there. That would leave a y plus 1 because I took the negative out. And then I'm dividing the 3 over there, which really makes it a negative 1/3 is our 4p. Is this the moment where you want me to say that I did not put a completing the square on the parabola section of the quiz? I did put one on the hyperbola, circle, and ellipse, but these are just nasty. The form, for some reason, is so troublesome. So you need to do a couple on some of on the worksheet, but I don't think I'm going to put this on the quiz. So here's more like what's on the worksheet. It doesn't have a coefficient. So we have an x squared plus a 20x plus a blank. If I subtract these over to the other side, I get a negative y minus 99. I complete the square, take half of 20 is 10, squared is 100. I add that to the other side. There was no coefficient out front to worry about. And I end up with a negative y plus 1. I do still need to factor out, because it's supposed to be in here, a y minus k. So this would be x plus 10 squared equals. If I took a negative 1 out, I'm dividing both of these by negative 1, so I actually get y minus 1 in here. So this would be x minus h squared equals 4p y minus k. So you would have k is 1, h is negative 10, and negative 1 is 4p, or p is negative 1/4. I'm going to actually go through focus and directrix for this one, because when it's negative, it's tricky. So just watch. I don't care if you write them down or not, but the vertex would be hk, so negative 10, 1. And this had an x squared, so the formula for focus is h comma k plus p. And while I'm looking at my sheet, directrix is h comma, no, sorry, it's not a point, kidding. Directrix is y equals k minus p. The issue, though, is that p is negative. So we got the vertex right here. For the focus, when I put in negative 10, comma 1 plus negative 1/4, that actually becomes negative 10, comma 1 plus negative 1/4 would be 3/4, or 0.75. And then the directrix would be y equals k, which is 1, minus p, which is negative 1/4, and minus that negative would become plus positive. So we actually get, for the directrix, y equals 1 1/4, or 5/4, or 1.25. I'm not going to be picky. All right, so there is one more example where you had a negative p. All right, so I think we still need to talk about these kind where you have some information. So what I did was I found the one where this number stayed the same on this sheet. So where the x value stayed the same was this one. So I knew right away, if the vertex and focus have the same x value, it's this form. Okay, same x value for vertex and focus. Use my recipe sheet, and that form was x minus h squared equals 4p times y minus k. And then I wrote above here that this is h, this is k, and the form says, on my sheet, it says that for the focus, I'm supposed to use k plus p equals negative 15/4. Well, I already know that k is -4, so I can find p. -4 plus p equals -15/4. If you type -15 divided by 4, and then, oh, I can't type. Then we were supposed to add 4 over there, I think. I got 1/4. Add 4, add 4. We get p is 1/4 or 0.25. And then we can write the equation because we know everything. So we put in here x minus h, which was -10, squared equals 4 times p, which was 1/4. And then this was y minus k, which is -4. So we'd end up with x plus 10, quantity squared equals 1, or just nothing out there, and a y plus 4. So we came up with this equation. Bottom line, conceptually, these are p units apart. So if you can figure out the difference between those, what I usually do when I'm doing these is I graph it. So I just do a super simple sketch. -10, -4 would be down here somewhere. And then this is actually -10, -3.75. So it is just a little bit above, which tells me it's opening up. And this was just a distance of 1/4. So I could have done the equation without all this fancy algebra, but it's fine either way. All right, number 11 has the k value stayed the same. So if I go to my reference sheet and I find, here the vertex and focus had the same k value, so that tells me it's going to open sideways. Okay, so I am using a general equation of y minus k squared equals 4p x minus h. Well, I already know h and k are 8 and 1. Right here, h equals 8, k equals 1. So I have y minus 1 squared equals, and over here this is going to be x minus 8. Now, conceptually, I would just sketch this. If I go over 8 and up 1, and this is actually at 7.51, so I'm going over 7.5 and 1, and that's the focus. That tells me it's opening this way, but it also tells me that p is 0.5 because the distance between those is p. And because it's pointing left, it's going to be a negative p-value. But let me do that algebraically. I know that h plus p is supposed to be 15/2, and I already know h is 8. And if I do 15/2 minus 8, I get negative 0.5, or p is -1/2. Okay? So I did it conceptually, I did it algebraically, and the last thing we have to do is plug it back in here. If this is a -1/2 times 4, we end up with a -2 right there, and we're done. All right. Then there's a couple where they give you the directrix. Again, if you look at your sheet, it will tell you when it is a x equals, you're using this formula. So you have h and k and an x equals line. An x equals line means this is opening sideways. And if you were to do a sketch, if you went over 3 and up 4, this is actually 3.75. So just a little bit before you get, or nope, let me see. Is that right? 11/4 is 2.75. Just kidding. Okay, so just before you get to 3, there was a line crossing here. So the distance between those, I can tell you right now, P is going to be 1/4, and it's going to open to the right. Okay, so, but algebraically, if you knew x equals h minus p, and you knew x was 11/4, and you knew h was 3, you could subtract. Oh, did I do this wrong? No, I didn't. Just kidding. You're trying to get the p by itself, Hofbauer. So you subtract 3. This is 2.75 minus 3 is a negative 0.25 equals negative p, though. So then when you divide by -1, you get p as 1/4. So that seemed a lot harder to me to do it algebraically than to just figure out the distance between those. But either way, this was a sideways opening parabola, so it was y minus k, which was 4, squared equals 4 times p would just be 1, and then x minus h was 3. All right, last one, I think. This is h is 6, k is 3, and the directrix is a y equals equation. So it's down here. When it says the directrix is y equals, then you know it's opening up or down. And the equation is k minus p for that. All right, if I were to graph it, over 6 and up 3 would be up in here, and 47/16 is 2.9375. That's disgusting. Okay, so if we went over 6 and up 3, and then we had a line at y equals just below 3, it's going to open up. But we can find that algebraically just by plugging all these values in. All right, so y is 47/16 or 2.9375 equals k, which is 3 minus p. So if I subtract 3, I get 0.0625 negative, or if I do a math enter, I get -1/16. So I have -1/16 equals negative p, or p equals 1/16. So it's just a 1/16 of a unit above and below. But all we need to do is fill it in. If it opens up, it's x minus h squared equals 4p y minus k, which is x minus 6 squared equals, if we put a 1/16 in there, 1/16 times 4 is 4/16 or 1/4, or you can put a 0.25, I'm not going to be picky. And then y minus k is y minus 3. All right, there's the last one. You do have to actually do one of these on the quiz where you're given either the focus or the directrix. So make sure you can do those kind, all right? So all your homework is to finish the last 2 problems on worksheet 3A, and then there's a Delta Math assignment. Please see in the lesson plans. It's called Parabola Practice or something. All right, have a great day.